Hi everyone, we are going to do our second example. We are doing some hypotheses testing for two proportions, and this one is going to concern water, and it was found that in recent years there's been a concern of lead contamination in drinking water in the United States. More than 20,000 wells nationwide were sampled by the U.S. Geological Survey, and again the actual link for this information is found in your textbook. In Virginia, 19% of the 2144 wells sampled had lead concentrations higher than the EPA action level. In Pennsylvania, so a different state, 12% of the 251 sampled were higher than the EPA action level. Do the data provide evidence that a higher proportion of wells contaminated with lead in Virginia than Pennsylvania? So Virginia is higher than Pennsylvania. Okay, so first step always is to write our hypotheses. So we do start with them being equal, and we will do Virginia. Yeah, Virginia came first, and then Pennsylvania. So PP, PV. And we are trying to find out if Virginia is higher than Pennsylvania. So again, in this example, we have a upper tail. If we had put Pennsylvania first, we would have had a lower tail. It will work out either way. You just have to make sure you're consistent with the way you subtract in that test statistic. Step 2 is to do those n pieces, that n times p1 and that n times p2. So if I'm looking at Virginia, I'm just going to put a V for Virginia. We're going to take that n, which is 2144, multiply it by our 0.19 on 0.19 times 2144, and I come up with 407.36. Okay, I don't know how you get part of a well. I'm guessing they probably rounded. So 2144, and this would be then 0.81. And we have 1736.64. Again, both numbers way larger than 10. For Pennsylvania, we had the 251 of our wells, multiplying that by 0.12, so 251 times 0.12 gives me 30.12. And if I take that 251 times 0.88, we will get 219.88. Again, way more than 10, so we can use our z-test. Step 3 is that test statistic. So the first thing I'm going to do is calculate that combined piece, so that p hat combined. And that is going to be taking that n1 times p hat 1, adding it to n2 times p hat 2, all over n1 plus n2. In our example with this n1 times p1, that's this number we got here. So that's my 407.36. We will be adding that to our 30.12. And we'll be adding our 2144 and our 251. So 407.36 added to 30.12. I get 437.48. Adding the bottoms. And then doing my subtraction, I come up with roughly, and I'm just going to round it to 3 decimals, 0.185 3. Excuse me. Oh, excuse me again. All right, so that's my p hat c. I have 182663883, so I'm just going to round it to 3 decimals. You could leave them in fraction form and work with the entire mess. This will be close enough. So now we're ready for our z, which the formula again is p1 hat minus p2 hat. And I'm going to write it in the form that is easier to work with on the calculator, which is going to be that p hat combined times that 1 minus p hat combined times 1 over n1 plus 1 over n2. Okay, and this subtraction does have to be done the same way you set it up. So we do want to take Virginia minus our Pennsylvania. So we will be taking the 0.19 minus the 0.12, because otherwise what's going to happen is you will be doing a upper tail, but you'll get a lower test value, so you'll kind of flip-flop the two pieces. Yeah. So here's my 0.183, and then I will subtract that from 1, and that's 0.817. 1 over this 2144 plus 1 over 251. And we'll get this value. Okay, hopefully I can push my buttons correctly this time. I didn't in the last video, but that happens even to us. So there's my numerator, and I'm going to divide by square root 0.183 times 0.817 times parenthesis 1 divided by 2144 plus 1 divided by 251. Close that off, close the entire thing off, hit my equal button, 2.71. Okay. There we go, 2.71. And now we're ready for our normal curve table, 2.71. 2.71 is 9966. So I will draw my little picture. There's my 2.71. We got 0.9966, but that would be from here down. So again, we will subtract 1 minus 0.9966, and we get 0.0034, which means step number 5 is to make our decision. Is this our p-value? Right there, that 0.0034 is, there's our alpha level, 0.01 is smaller than the alpha level, which means we are going to reject H naught, which means we will say there is enough evidence. And I'm not going to be able to get it on this piece of paper, to show that the proportion in Vermont is larger than the proportion in Virginia. Well, not Vermont, I guess Virginia and Pennsylvania. That the lead contaminate proportion of high lead is more so in Virginia than in Pennsylvania. In other words, we like that statement. Hopefully this helps. Sorry I ran out of room, but you have seen quite a few of these statements as we've been progressing through these videos, so hopefully they are making sense for you. One more video to go in this unit.